Adding touch controls to your game so that they can be played on touch-enabled devices requires a lot of patience. There's a lot of steps. Make sure you have some notepaper handy and that you watch this video all the way through before trying to perform any of the steps. First thing we're going to do is Windows E, Colstock Game Dev Space Shooter, and we're going to launch our Space Shooter project. We need to make a couple changes so that our game plays well on touch devices. The first thing we're going to do, we're going to change the window size of our project to 800 by 1200. So now it's going to be 1200 pixels tall, the window that the user sees. We're also going to change orientations to be portrait. This game is going to play best on a device in a portrait orientation, not landscape. We need to go to our start layout and change its layout size to match 800 by 1200. When we do that, you'll notice that our start plate isn't centered on the page anymore. What we're going to do is we're going to select this, right click, and we're going to align everything on the layout to center vertically to the window. We need to do the same thing on our end layout. We're going to change the layout size to 800 by 1200 minus to see that our game over and you win plates are no longer centered. Select them, go to Align, Window, and center them vertically. As you can see, both the win and lose plates are centered given our new layout size, 800 by 1200. Okay. Take a moment to confirm that everything is centered and as it should be, considering our new dimensions. Similar to the keyboard and the mouse object, Construct 2 has a touch object. The touch object needs to be included in your project before you can do anything with touch controls. So let's save our work and scroll down to Object Types. We're going to right-click Insert New Object. We are going to insert the touch object and press Insert. You'll notice that there's a property called Use Mouse Input. This is going to come in handy pretty soon. For now, leave the value at Yes. Go to the Start Event Sheet. The Start Event Sheet is associated with the Start layout, so all this code runs at the beginning of the game. We're going to add a global variable. We're going to add a global variable called Device Type. It's a text variable that will store the value touch if we have detected that the user is on a touch-enabled device. By default, there'll be no value. What's going to happen is at the beginning of the game, we're going to be detecting whether someone has used a touch-enabled device, and we're going to store the value touch in the device type variable. Now we need to add the code that will detect whether the user is on a touch-enabled device. We're going to add a sub-event to the Start Sprites is visible event. I'm going to choose a touch object on any touch start, and we're going to set a global variable, the one we just created, device type, to touch if we detect that any touch event has started. We also want to copy and paste our go to layout, space layout action right after that. This is where we're doing our device detection. Okay. We've done our device detection, which means we've determined whether the user is on a touch device and we've stored it in a variable. Now we need to add a touch layer to the space layout. Make sure all the other layers are locked. Create a new layer called touch. Make sure it's on the very top. Set its parallax to 0, 0, so it's always pinned to the screen. And by default, this layer is going to be invisible. This is the layer we will be placing our touch controls upon. Make sure it's invisible and that its parallax is 0, 0. We're also going to add an event sheet, touch event sheet. This event sheet is used exclusively for events that have to do with handling touch events. Before watching this video, you should already have the Kenny Donation assets downloaded to your flash drive and extracted. As you can see here, I'm using version 37. If you haven't done that, pause the video and do so now. Otherwise, we're going to head off to the Art, On-Screen Controls, Vector, and we're going to be using the Flat Dark controls. We're going to be opening those in Inkscape, which is the program we use to manipulate vector files. Remember, it's plus and minus to zoom. At first, all of the contents will be grouped together. Select them and Control U to ungroup. Control U to ungroup. Now you can see all the individual paths. We want to zoom in. What we really want is that big round black circle. This is going to be our touchpad. We want to export it at 250 by 250. Make sure you're exporting all of your custom raster files to your assets directory and naming them logically. This one we're going to call touchpad, flat dark, 250 by 250, and then we're going to export that using Inkscape. This is the dial that people will be touching to control the spaceship if they're on a touch device like a phone. Go back to the space layout, make sure that the touch layer is active, go to projects, and we're going to add a new sprite object type for our touchpad. Go to sprite, we're going to call it touchpad, capital T, capital P. And insert. Open the folder and navigate to the raster file that you just exported. Click the red X to close. We're going to change the opacity and the position. We're going to make it half see-through by making the opacity 50, and we're going to position our touchpad at a 175X coordinate, 1025Y coordinate. This is the touchpad that users will see if they're on a touch-enabled device. They'll be able to click on it and control the ship. We're going to need some programming for that, so we're going to add instance variables to the touchpad. The first instance variable is going to track the distance of the user's touch from the origin point. In other words, the center of the touchpad. If the user touches too close to the center of the touchpad, we're not going to do anything, but if they touch far enough away from the center, we will make the spaceship move. To do that, we need another instance variable. Call it degrees. Degrees measures the angle, the location on the circle that the user has pressed. Once again, user will only see touch controls if they have a touch-enabled device, and we need these instance variables to keep track of where they pressed on this pad. The pad controls the spaceship. Let's stop a moment to talk about next steps. We're going to be using a couple built-in formulas, distance and angle, to determine where the user touches on the pad if they have a touch-enabled device. When we figure out the angle, we will use that information to control the spaceship by making it simulate movement in one of the 8 directions. Start by adding a group, call it touchpad. All the events that have to do with the touchpad and controlling the spaceship using its 8 direction behavior will be placed in this group. Let's add an event. Choose the touch object, is touching object, and choose touchpad. And done. When the user is touching on the touchpad, let's set the value of the touchpad's distance instance variable. And we're going to use that distance formula that I showed you in the previous slide. If you need to, pause the video and go back and grab it. Once again, if the user is touching on the touchpad, we're going to set the distance instance variable to what comes back from this distance formula. This distance formula is finding the distance between the center of the circle and where the user touched. That's all it's doing. We need to add a sub event. First, we're going to place this event within the group itself. Here we go. Right click, add sub event. Okay. Touchpad. And we're going to compare an instance variable. Once we've determined the distance by using the formula, we're going to compare it to the overall width of the touchpad divided by 10. This is just a way to make sure that the touch that we're handling happened far enough away from the center of the circle. That's all we're doing here. If the user touches far enough away from the center of the circle, then we should be able to determine their intent. To do that, we use the degrees instance variable of the touchpad. So we're going to add an action to set the value of the touchpad and its degrees instance variable. The degrees instance variable is going to be set to the result of this angle function. The angle function is very similar to the distance function. It takes 2 points in, each is x and y coordinate, and determines the angle from each point. In this case, we're determining the angle from the origin, the center of the circle, and where the user touched. Once we know this angle, we can compare it to a range of values to determine which of the 8 directions to send the ship in. So we're going to add a whole bunch of sub-events. We're going to be using the touchpad's degrees instance variable. We're going to be doing a bunch of comparisons on it. Our first comparison checks to see whether the user clicked on the right side of the touchpad. We're looking to see whether the value of the degrees instance variable is greater than negative 22.5. Let's add another condition. Touchpad, compare its instance variable, and less than or equal to positive 22.5. If the angle is in that range, then we know that the user wanted the ship to go right. So we add an action using the spaceship. In its 8 direction behavior, we use simulate control, and we choose right. So there's going to be 8 different comparisons to figure out where did the user touch on the pad, and therefore, which of the 8 directions should we simulate. Please refer to this diagram as you complete the code. There are 8 comparison ranges that you need to compare the degrees instance variable to. Depending upon which range the degrees falls into, you will simulate a different one of the 8 directions. When you're done, it should look something like this. One thing you'll notice is that some of the directions require you to simulate right and then down, or left and then up. Once again, refer to the previous slides when completing this. We're going to go ahead, however, and we're going to deactivate this touchpad group. Press Edit and deselect Active on Start. I'll explain more about this in a minute. We need to add an event, an onStart of layout event, which will show our hidden touch layer if the user is on a touch-enabled device. So scroll down, find the onStart of layout event, and we're going to need a sub-event. Right-click, add sub-event. We need to look at the value of the device type global variable. If it's equal to touch, then we are going to make the touch layer of the space layout visible. Remember, the touch layer by default is invisible. Another cool thing we can do, we can activate code groups under certain conditions. In this case, we're going to set our touchpad group active. But remember, we're only going to set this active if the user's on a touch device. In other words, the device type global variable must have the value of touch. All right, let's collapse that. We're going to move this to the very top. See how it's grayed out? That means it's initially disabled. Our code, however, will enable it if device type equals touch. Let's go to our space event sheet. It's not enough to have a touch event sheet. We need to include it in our space event sheet. You can include event sheet in as many other event sheets as you want. Remember, every layout has an event sheet, but you can include other event sheets as you see fit by choosing right-click and then include event sheet. For testing purposes, we're going to go ahead and use that nifty feature to deactivate our enemy's code group. This way we can test without having meteors flying at us. We're going to make a couple changes to the game. Specifically, in the spaceship event group, we're going to add additional conditions to the code that controls the scroller. Remember, the scroller is what limits where the spaceship can go. We're going to add an extra condition. We only want our current behavior if device type is not equal to touch. Additionally, we're going to change it a little bit. Now that we have a higher, larger layout, we are going to let the spaceship lag 750 pixels. Down below, there's an event that limits the spaceship from going past the scroller. We need to add an additional condition to that as well. We like this behavior, but we want to limit it to when the user is using a keyboard and mouse. In other words, when device type not equal to touch. We're going to be adding two events to this event sheet that define the behavior we want for when device type equals touch. When device type equals touch, we want slightly different behavior. We don't want the spaceship to run into the touch controls. So first, change the condition. When device type equals touch, we are only going to permit the spaceship to lag the scroller by 400 pixels. This will keep it out of the way of the touch controls. We're going to change the behavior below a little bit. We're going to copy and paste this event, change where it says device type not equal to touch to device type equals touch. When device type equals touch, we will allow the spaceship to move a little bit ahead of the scroller. We're going to let it move 400 ahead, but no more than that. So we're going to make the appropriate code changes. So if the device type is touch, we have a certain set of behaviors, and if the device type is something other than touch, then we have the default behavior, which is to let the spaceship lag 750 and not pass the scroller. But because we have touch controls, we change that if the device type equals touch. There's one more small change we need to make to accommodate touch controls. Go to the end event sheet and first make the on click of the restart button an OR block. And let's add another condition. Choose touch. On touched object, restart. And done. Now we'll be able to restart the game whether someone clicks on restart with a mouse or touches it with their finger. Believe it or not, we are ready to test. Test in debug mode. We're going to test whether the device detection is working. If device detection is working, you should see touch controls when on a touch device and not see them when using a keyboard. Right now we're using the mouse to simulate touches. As you can see, the global variable has been set to touch. See how you see the pad? Test it out, see if it works. Notice how, depending upon where you touch on the pad, the spaceship is moved accordingly. You'll also notice that the spaceship will not drop below where the touch controls are at. What happens, however, if I'm using a keyboard? So let's go ahead and try to launch, and this time don't click with your mouse. When the start button appears, hit your space bar. If you hit your space bar, then the device type global variable won't be set to anything at all. In other words, it won't be equal to touch. Notice how you cannot see the touch controls. That's because the touch layer is still invisible. Additionally, notice how the default behavior for the scroller is in place. You can't pass it, but you can lag much farther behind it than when touch controls are present. Now you should have a working touchpad to control your spaceship. Before moving on, let's take a look at our touchpad real quick. Remember, we're on the space event sheet, and the touchpad is on the touch layer. It's really important that our collision polygons are really generous whenever you're dealing with touch controls. So in the touchpad, I'm going to go ahead and I'm going to be extra generous and pull each point of the collision polygon out. I want the user to have the most success, most opportunities clicking on the touchpad. Go back to the vector, and we are going to choose this little fire button down here in the lower right hand corner. We're going to export it at 150 by 150, and once again we need to export this to our Colestock Game Dev Space Shooter Assets directory. This is a fire button that we're going to use on touch controls to let the user fire off bursts of lasers. So with the left hand, they'll be able to control the ship, and with the right hand, they'll be able to shoot bursts of lasers. Export that raster image to your assets directory. Go back to your project, make sure that you're on the space layout touch layer. Right click object types, and we're going to include a new object type. I'm going to call it fire. Click on the touch layer, click on the folder, and choose the fire button raster image you just exported. Be real generous with your collision polygon. Click the red X to close. We're going to make this fire button 50% opacity, and we're going to position it at 675, 1025. This button is going to control bursts of lasers. So before we can code that, we need to put some instance variables on our spaceship. Scroll down to the spaceship, right click, instance variables. We need instance variables to control the firing of the lasers. Add one instance variable called isFiring. By default, it's 0, which represents false. And this instance variable is used to indicate whether the spaceship is currently firing a burst of lasers. Let's add another one. This one's going to be called shots fired. This keeps track of how many lasers in the current burst have been fired already. By default, it's 0. Both of them are numbers. Go ahead and close that out. We need to go to our touch event sheet. We're going to add a group. That group is going to be called fire button. Any event that has to do with firing our laser burst will go in here. We need a global variable. This is going to be called shot count. This is a global variable that defines how many lasers to fire in each burst. We're going to go ahead and shoot 10 at a time. So user can click the button. It'll fire 10 lasers. It'll also block them from trying to fire lasers during the time that it's bursting. Let's add an event. Choose our touch object. On touched object of the fire button. Press done. Let's go ahead and move that into our group. Let's add a couple more conditions. Let's choose our spaceship. And we want to look at the is firing instance variable. We're looking for where it's not equal to 1. In other words, only if the spaceship is not currently firing and when the spaceship's shots fired instance variable is equal to 0, which means it has shot none of the lasers in the burst. If all these conditions are true, then we will let the user fire the laser burst. The first thing we do, we set the value of is firing to 1. This indicates that the lasers are currently firing and will block subsequent touches from firing the lasers. Let's add a sub event, a for loop. We're going to name that loop fire. We want our loop to loop 10 times, 1 to the value of shot count, which is currently 10. So construct 2 will execute this loop, the action within it, 10 times. The first thing, we're going to issue a wait. 0.2, which is 200 milliseconds, times the loop index. The loop index is like a counter. The first iteration of the loop is 1, and the 10th is 10. So what we're doing here is we're scheduling the firing of our laser. Go over to the space event sheet, copy the 4 actions associated with firing lasers. Shift click all of them, then Control C. Go back to the touch event sheet and paste them in underneath the wait action. And then finally, each iteration of the loop is going to fire lasers. For every laser fired, we want to add 1 to the spaceship's shots fired instance variable. Remember, we're shooting 10 lasers in each burst. Okay, let's add an event. System compare variable. We're going to compare the value of the shot count, the amount of lasers to fire in a burst, to the spaceship's shots fired instance variable. When these two things are equal, what that means is that the laser burst is over. When the laser burst is over, we want to set the spaceship's shots fired instance variable back to 0. And we want to set its is firing variable back to 0 as well. This will allow the user to touch the button again and to get a new burst of 10 lasers. Go ahead and move this into the group. Save our changes. Just like we did before, we are going to deactivate this group. And the onStart of layout event for the touch event sheet will determine whether to activate it. Remember, we only want these groups, these blocks of code, to activate if we are on a touch-enabled device, if the device type global variable equals touch. Let's go back to our space event sheet. Now, we need to change how our lasers fire. We need to add a condition that checks for device type. If device type is not equal to touch, then we want the default behavior, which is for 5 lasers a second, to automatically spawn from the spaceship. However, if we are using touch controls, we want the user to have to click on the fire button. The touch object has a cool property called use mouse input that allows you to simulate touch using your mouse. During testing, set this to yes, but when you deploy your game, set it to no. Run your game in debug mode. Notice how device type is nothing right now. Use your mouse to simulate touch, and when you click on start, you will see that device type equals touch. You can see both the fire button and our touchpad. Notice how no matter how many times you touch on the fire button, it will only shoot one sequence of 10 lasers at a time. This is a great way to use the mouse to do your touch event testing. Let's do some negative testing. Let's try to test it using just our keyboard. Notice how the touch layer with the touch controls is invisible, and how device type is not equal to touch. It's totally blank. Lasers are firing 5 a second, and it requires no user interaction whatsoever. Let's get ready to publish our game and test it out on a real touch device. Go back to the touch object and set use mouse input to no, because we're going to test this on a real touch device. Go to your space event sheet. Let's re-enable the enemies so that we can get meteors, so we can do a full test of our game. Our next step is to export our project, but before we do, Windows E and go to your flash drive, Colstock Game Dev Space Shooter HTML5. Control A and delete to get rid of the files. This is where we're going to be placing the files we export. Go to File, Export Project, and choose HTML5 website. Make sure that these exported files are going on to your Colstock Game Dev Space Shooter HTML5 directory. When you've verified that, click Next and Export. We're going to be using FileZilla to transfer these exported files to our class website. Just to make things easier, we are going to delete whatever files are currently in the Space Shooter directory on our class website. Launch FileZilla and log on to our host with your username and password. When you connect, go to public HTML, go to your Space Shooter directory, select all the files in there, Control A, and delete. On the left side, make sure you have your Colstock Game Dev Space Shooter HTML5 directory selected. Control A to select all and drag those to copy them to your class website's Space Shooter directory. Just be patient. And once all the files have transferred, you'll be able to test your game on a mobile device. I'm testing this game on a tablet. I'm going to go to my class website. Make sure you specify space-shooter on the end. Wait for it to load, and we're going to test out the touch controls for real. Hopefully they're big enough and they're responsive. Remember, the touchpad is going to control the 8-direction behavior of the spaceship, and the fire button shoots bursts of 10 lasers at a time. Looks like everything works pretty well. Remember, this game works best in portrait mode. It's a little small in landscape, not as much fun to play. Now that you've watched the video and you've taken notes, go back and try these steps for yourself. If you have any questions, just let me know. Thanks a lot. Have a great day.